This is the 2007 question 4b. We have this diagram here with all our masses are 4 and our 6, and we have B in the middle with 2 strings attached. So we're looking at the accelerations here. A, B, and A plus B over 2. So let's set up our different diagrams. We have our 4 kilo. We have 4G coming down. We have T going up. We have our 6 kilo. Yes, that is the dog snoring in the background. I gave her a sedative so I could make these videos. T going up. So let's look at our B as well, with our 2T. And there we have a mass for M, not just M kilograms for B, so mg. So what are we asked here? We're asked on separate diagrams, so we just need our acceleration and then find in terms of M the tension. Okay, so if we imagine B coming down, the other two going up, we have our A plus B over 2 in this direction. So we call this one A and this one B. So we set up our equations. So the 4, we're going to have T minus 4G is equal to MA. For 6, we're going to have T minus 6G is equal to 6A. And for B, we're going to have mg going down minus 2T is equal to M, which is just M times A, which is A plus B over 2. So if we get A and B from the first two equations and sub them into the third one, we can say that A is equal to T over 4 minus G, and B, we call the second one A, that should be 6B. 6B, you're all saying, I'm sure you saw it. B is equal to T over 6 minus G. So we get A plus B over 2. A plus B is equal to T over 4 minus G plus T over 6 minus G, which is, think about good to 12, so that's 3T over 12 plus 2T over 12, that's 5T over 12 minus 2G, that's A plus B. So A plus B over 2 is going to be equal to dividing both of these by 2, 5T over 24 minus 2G over 2, which is just G. So we sub this into our third equation now. We're going to get mg minus 2T. We're asked for T, aren't we? Find in terms of M the tension in the string, so we're looking for T. So we have mg minus 2T is equal to M times 5T over 24 minus G. Need to get T on its own, so we're going to have mg minus 2T is equal to 5mt over 24 minus mg. So that's 2mg is equal to 2T plus 5mt over 24. If I divide by 2, I'm going to get mg is equal to T plus 5mt over 48. And factoring out T, I'll get 1 plus 5m over 48 will be equal to mg. So simplifying that bracket, 1 plus 5m over 48 just be the same as 1 over 1, so it'll be 48 plus 5m over 48. So T will be equal to mg divided by that fraction, so that'll be the same as turn it upside down and multiply. So 48 over 48 plus 5m. So tension looks to be 48 mg over 48 plus 5m. Are we told that's what it is? No, we're just asked to show it. That's what we're asked to show. That's what we've gotten. If m is equal to 9.6, prove that pulley B will remain at rest while the two particles are in motion. So we're told that m is equal to 9.6. So let's see what's going on here. We have A and B up here, don't we? M is equal to 9.6. Okay, let's see what T is equal to then. T is equal to 48 by 9.6 by 9.8 over 48 plus 5 by 9.6 is also 48. Okay, so can I simplify it without a calculator? That's on top, 48 by 9.6 by 9.8. On the bottom we have 48 by 2. So they'll cancel. And 2 will divide into 9.6. 4.8. So we 4.8 by 9.8 for the tension in the string. So that will simplify to be 4.8 G. I think that will help them for A and B. Let's have a look at A and B. A is T over 4 minus G, and we've T over 6 minus G. T over 4 minus G, and T over 6 minus G. So let's have a look here. We've got 4.8 G over 4 minus G, so that's 1.2 G minus G, so that's 0.2 G for my acceleration. And on this side I have 4.8 G over 6 minus 1 full G, so that's 0.8 G minus full G, which is minus 0.2 G. What were we asked? We were asked, if m is 9.6, prove that pulley B will remain at rest. We're actually asked for the acceleration of B, so a plus b over 2. Okay, so we can see that's going to be 0. A plus b over 2 is the acceleration of pulley B, which is 0 over 2, which is equal to 0. Therefore, does not move. Like some applied maths students on a Sunday morning.